Okay, class, this is the pre-lab questions for the vinegar lab that we're going to be doing, the vinegar titration. These pre-lab questions that are on the screen right now are not the ones that I'm asking you to turn in to me. The ones I'm asking you to turn in are vinegar pre-lab questions on page 7. They look almost exactly like this, except some of the numbers are different. I'm doing these on here in the screencast as an example, so please don't turn in exactly what you're writing down here from the screencast. I want you to take a look at what we've done here and then do the same thing for the page 7. I hope I'm being very clear about that. There's still going to be some people who are going to turn in the wrong thing. I don't want you to turn in this. This is my example to you. Okay, I want you to turn in page 7, which is also on the assignment, separate from the whole vinegar lab, which is 16 pages. Okay, so let's get started with the first question. It says, what volume of 6 molar sodium hydroxide solution is required to make 500 milliliters of the 0.1 solution? So this is clearly a dilution. This is a dilution equation that looks like this. So our starting concentration of M1, which is what this would be, times V1 equals M2, which is what this one is down here, times V2, which is what V2 is here. So the only one we're missing then would be the V1. We don't know what that is. Okay, so if I solve this whole equation here for V1, then it looks like M2 times V2 divided by M1. Okay, so what is M1? Is always the higher concentration, that's the 6 molar. The V1 is what we're looking for. M2 is the lower concentration, or the 0.1 molar, and V2 is always the higher number. So whatever number we're going to get for V1 is going to be less than 500 milliliters. It has to be for a dilution problem. So once I plug these in, I end up with 0.10, that's the molarity, that's M2 times V2, which is 500 milliliters, like that. And we don't have to change milliliters this time, which is nice because we will have to change it for other things. But once I multiply these two and divide by 6, I end up with 8.3 milliliters. That's what I'm left with because the molarity cancels. And that's my V1 right there. So there's the answer. That's the amount of the extra concentrated sodium hydroxide that we would need. Okay, let's move on to the next one. Now this is one of those things where in a titration we have to know exactly what the concentration of the sodium hydroxide that's in the burette. We need to know what that is, and one of the ways we can figure that out is by accurately measuring the mass of a simple acid and then titrating that with the sodium hydroxide that we have. Okay, so once we do that, then we know what the sodium hydroxide is. And then we can find, using the known sodium hydroxide, what the concentration of an acid is, any acid then, by titrating it with a known amount of sodium hydroxide. So let's see how we do this. This, I should let you know, KHP is potassium hydrogen phthalate. It has a formula weight of 204.23 grams per mole. Okay, that's good to know. You should also know that KHP reacts with sodium hydroxide, and on the other side we form water, as we do with most acid-base reactions, and sodium potassium phthalate. Okay, now, that's all you need to know, that it's a 1-to-1 ratio, because that makes our math then a lot easier. Let's start from the beginning now. Suppose we have this amount, the 0.8672 grams. So we're going to put that over 1, like we always do, and we're going to change KHP from grams to moles. I do that by 1 mole on top of KHP is the same as 204.23 grams on the bottom, like this. And what I get then after that calculation is 0.004246 as my number of moles of KHP, just like that. Now, here's the nice part about this. Once we got the number of moles of KHP, here's what you should know. that whatever the number of moles that we've titrated with sodium hydroxide, that means the moles, let me scroll down just a little bit, give myself some more room so I can explain this to you. Because this is a one-to-one reaction here, whatever the number of moles I have here, 0.004246, that's the number of moles that will react with the sodium hydroxide. So the amount of sodium hydroxide moles that will react with the KHP will be the same number. They are equal to each other. Okay, so KHP, when it stops reacting, that's the amount of sodium hydroxide that has reacted. So that means that these two numbers are equal to each other. So the number of moles of sodium hydroxide then would be equal to 0.00, and this is only because it's a one-to-one reaction. 1 mole of KHP reacts with 1 mole of sodium hydroxide. So what I can do is I can say that I have this number of moles of sodium hydroxide because that's the amount that reacted. And then I simply divide number of moles divided by the amount I have. Now here's another part that's a little bit, just a slight bit tricky, is notice that we have the number of milliliters, 28.15 milliliters, but we need to change that to volume in liters so that we can use it in our equation, because molarity is moles per liter, not moles per milliliter. So when I change milliliters to liters, I go 1, 2, 3 places, and I put the decimal point like that. So let's take this back down to where we were. Down here, I'm going to simply, just like I said, molarity equals moles, which is what we have right here, per liter, which is 0.02815 liters. That's the 28.15 milliliters changed to liters. And then I divide those two, so that means that sodium hydroxide has a concentration of 0.1508 molarity, and that's the sodium hydroxide. Okay? So this part right here, where these two are equal to each other because we titrated them or we reacted them, that's the important part. Next one, number 3, phosphoric acid titrated with, now take a look at this. This no longer is a 1-to-1 ratio. Okay, this is no longer a KHP and NaOH. Now it's 1-to-3. And this part right here with the OH minus means the NaOH. Okay, so what's the mass of the phosphoric acid in the solution? Well, let's start off with the mass of, or let's find the amount of sodium hydroxide that reacted. And we can do that. We want to find the number of moles, and we can do that by taking concentration times volume, like that. Notice our volume, again, is in milliliters. So there's going to be many times when you're going to have to move the decimal place, 4356. There we go. So that you get liters. So what does that mean? That means I have molarity right here, a 0.1342, that's the molarity, times the liters of 0.04356, like that, liters. And what we get then for the number of moles is 0.005846, and that's the number of moles of sodium hydroxide. Okay? Excellent. So that's the number of moles of sodium hydroxide. So all we did was find the moles. We did that by using molarity equals moles divided by volume. That's all we did. And I solved for moles then, which is molarity times volume. Okay? So now this says what's the mass of phosphoric acid? Well, there's a couple of things we need to do. The first step we need to do, and I'm going to start down here, is I need to start with the number of moles of sodium hydroxide and then change that to moles of phosphoric acid. That's actually a lot easier than it sounds like. So this is the sodium hydroxide. All of that over 1, and then I'm going to multiply by, and I'm going to use these coefficients then to make this happen. So that means 3 moles of NaOH on the bottom and 1 mole of H3PO4. Once I have that, all I have to do now with 1 mole of H3PO4 on the bottom here is multiply by the mass, the gram formula mass of phosphoric acid. So I have 3 times 1.0, which is 3.0, like that. I have 1 phosphorus, remember it's H3 PO4. Just want to make sure you're following along. That's 31.0, I believe, like that. And then I got 4 oxygens. Each one is 16.0, which is 64. And then when I add all of those up, what I get up here is 98.0 grams of H3PO4. And then when I take this number, the 0.005846, divided by 3, multiplied by 98, what I end up with then is 0.1910 grams of H3PO4. And that's how you do that. Okay? I try and keep the video as short as possible. Please don't turn this in. Please do the extra work to do page 7. Thank you.